First of all, thank you for joining our webinar. My name is Mike Robinson. I'm with Design Software International. You've joined the webinar today on advanced programming techniques within the machining extensions in Fusion. As I mentioned earlier to a couple of the early attendees, I will be answering Q&A as we go through, so you can actually pop a question in that section or via the chat. I'll do my best to answer. I'm also going to post an email address there for anything that comes up after the webinar that you may feel, oh, I should have asked this question. And I'm actually going to post that in the chat as soon as when I pass over to my colleague. And really, without further ado, I'm going to pass you over to my colleague, Devon Dupuis. Thank you.
And with that, we can get into the technical portion of the webinar. Real quickly, I'll just give a brief introduction. My name is Devon Dupuis. I'm a Fusion 360 subject matter expert here at Design and Software International, 10 plus years manufacturing experience, and my specialties are 5-axis CNC machine programming and advanced manufacturing techniques. Hopping into Fusion 360, we'll start off with this mold part. And essentially what we're going to do is we're just going to hop from design to manufacture and look at how some of the features inside of the machining extension can help us with processing a part like this. First thing I'm going to do is go to setup. I'm going to start creating my setup. You can see that Fusion selected the body for me already. I do have a machine selected here, UMC 500. And I'm going to add some of my fixtures here. And then I actually have a custom stock for this. So we'll set this as a solid and I'm going to grab my stock and that looks pretty good. And we're going to hit OK and our setup is created. So from there, I'm going to start machining this part. And the first thing I want to do is rough this out. Now this is something I do fairly often. So what I'm going to do is I'm going to right click on the setup here and I'm going to say create from template. And I have this arrow roughing template. It's going to drop that template in here and I can right click on this and just hit generate. That's going to go through and rough that out for me. And we can right click on this and simulate it because I'm imagining I'd probably want a little bit more definition. We can hit play on this. We can see this going through. And that looks pretty good. We can turn this to transparent here to see there's a little bit extra material on there that I probably want to get with a rest machining operation. So what I'm going to do is I'm going to take this and I'm going to duplicate it. And I'm going to go into the second version of the toolpath and I'm going to change the tool. I'm going to use this. We'll alter my step over here to like 0.1. And we'll go to geometry and I'm going to use from previous operations. And then because I want to have a fairly consistent tool pressure when I'm finishing this, we're going to increase this to 1 inch and we'll make this 0.1 for our step up there. And then I'm going to make this leave only 10 thousandths. One other thing with this smaller tool, I don't need to go all the way to the bottom of my model. So I'm going to limit that by just saying selection. We'll make this reference be 0. And I'm going to zoom in here and I'm going to touch that face. Hit OK. That should give us a pretty good rest material on pretty good finishing strategy, get all that extra material off of there. And if we want to see the model in process, we can turn this on right here and click on these individually and we can see kind of how that's helping us with our model. So from there, I have the part mostly roughed out. Now what I would like to do is finish all the flat areas on this part. So I notice there's some areas here and especially this part here. I'm going to go into 3D. We have this flat operation and I'm going to use the same 1/4 inch end mill just to get into these areas pretty tight. And we'll just hit OK. We're not going to make any selections there. We'll let that generate. That looks like it does a pretty good job of finishing those areas. Now, here's where we get into, I would want to use the extension for this. So we could go through here and put like a parallel toolpath on this, and we'll change the end mill here to a finishing end mill. And I'm just going to hit OK. This is kind of how I like to start out 3D toolpaths, just by selecting a tool and then just making very minimal changes. I'm going to change this over here so we can see kind of what it's doing. So I'm going to say 0.1, and then I'm going to rotate my path direction here 90 degrees just to accentuate this situation. So there we go. And let's turn off the stock so we can kind of see this. So this 3D toolpath here is kind of doing what we want, right? This is a raster style toolpath. So it's going just striping across the part here. So if we look at it from the Z-axis normal from the top, we can see that it's doing exactly what I've asked it to do. The issue here though is there's some pretty wide step overs based on where the toolpath is looking at, and that's just based on how this is calculated. And in here, what we'd probably want to do is segment these surfaces. We'd want to pick what surfaces we'd want to do for this toolpath, and then choose other toolpaths for different surfaces and whatnot. And that might be pretty time consuming to go through this whole part utilizing that strategy, because there are quite a few different faces here. This toolpath is actually really good at areas of high slope, as long as they're in the cut direction, but areas of high slope that are opposite the cut direction here, we can see that the spacing is pretty wide. So let's delete that toolpath. And I'm going to go into 3D here, and we're going to use steep and shallow. I'm going to again select that finishing end mill, and here I'll grab it from my document. And if we go to geometry here, it's just doing the silhouette of the model, which is the whole thing. And I want to avoid the flat areas, so I'm going to turn this checkbox on. And then we'll go over here to passes, and we'll change a couple settings. So we can actually leave these scallop, continuous. You can alter between the toolpath styles here. We might want to change this to parallel later. Let's just hit OK and see what we get. And remember, we've already roughed this part out and finished all the flat areas on it. That looks pretty good. I'm not seeing anything that I don't really like, except the top here. I'm not a big fan of this style of toolpath kind of collapsing in there. So let's double click on the icon. It'll bring us here to edit, and we can change this to a parallel. I'm going to make this go both ways. And then we can hit OK and see if we like this version of the toolpath. While that's calculating, we can continue machining because it's going to calculate in the background. But it looks like it's done, and that looks much better. A little bit more what I was expecting. So we could simulate this as far as the process goes, or we could just take a look at this model as we have it so far. That looks pretty good. What we're going to want to do now is process these holes. So we could go through here and make all these drilling operations just by hitting drill, by finding a drill, and then we'd have to come in here to each one of these and say tool orientation. We'd have to select our orientation. In this case, it would be this one. And we'd have to select our face here like that. Then we'd have to go and set our drilling cycle to what we wanted it to be. And then that would give us all these different orientations. So we'd have to do this for each face, not only the flat face, but all these angular faces. So in the extension, what we can do though, is we can grab this hole recognition and we can turn this on. Now this is going to quickly analyze the model. Now by default, you can see it's not gathering those other holes that are on here. And there's a reason for that. So by default, it just works in 3-axis. So we'd have to go over to the options page and turn on multi-axis machining. When we check this, it's going to analyze the rest of the part, and it's going to give us the other holes that are on here. I can see a few other holes are on here. Now, one thing I'm trying to pay attention to is the Z-axis for each direction of these holes. Now, this one would be okay. This one looks like it would be okay. This one also looks like it would be okay. And that one is the right orientation also. But this one here, I wouldn't want to drill these holes from the back side because we're not flipping the part out and working on the back at this point in time. So what I'm going to do here is I'm going to grab this segment, this selection of holes. And down here, there's a couple things where we can split out this group, and we could do them each individually if they had to be different items. But what I'm going to do here is this one is flip hole direction. So when I flip that hole direction, that's going to give me this orientation to machine those holes. And then we can choose what these are. Maybe some of these need to be reamed or tapped. We can choose those options from there. Now I'm just going to hit OK. So instead of doing each one of those individually, we can see that this went through and it processed all of those holes directionally and made us not only the spot drill, but all the drills for that, because that is what I selected. And that looks pretty good from there. Now, one thing, if we take a look at our steep and shallow here, and we turn off this model, this looks pretty good, but I forgot to look at this before, and I do see there's some 3D machining going on in these holes. Now, obviously that's undesirable, and I wouldn't want that to happen. So there's a few different ways we could adjust this by making some sort of boundary or whatnot, but I'm going to show you two ways here. So I'm just going to look at the top of the model with the toolpath selected. I'm going to go over to modify, and I'm going to go to delete passes. Now with delete passes, we can do a couple things. I can just do a circular or a box selection here and select that region, and I can hit OK, and it's going to get rid of that region. So I could repeat that for all the other regions. The other thing, once we make a modification here, it will display this little pencil, and that's going to show that we have made some sort of modification. It will also give us this timeline down here in the lower left. And when I hover on the delete passes, you can see up there shown in red are the segments that I deleted. So let's right click on this, and I'm going to say delete. I'm going to do a little bit different of a process for trimming this up. So I'm going to go to modify, and instead of delete passes, where I'm picking actual passes or segments, I'm going to go to trim. And with trim here, you can see I have a couple options. I have trim type, polygon. So I will probably just draw a polygon. We could also trim this to a plane, because some of my toolpaths also live on this plane. We probably wouldn't want to use a selection. We could also use a boundary. So I could select boundary and grab something like this outside chain here and then offset it by a certain amount. But what I'm going to do is I'm actually going to be picky, and I'm just going to just draw my own boundary here. So I'm making a couple quick selections on the screen, and it looks like I've encompassed everything that I would want there. So I hit the plus sign, and I want to keep the inside of this. So I'm just going to hit OK. And then that's going to regenerate that toolpath. So no matter what changes I make to this, if I make this the step over bigger, wider, anything like that, it's always going to replay this edit. And I can show you that here real quick. Let's just go into passes here, and we'll say that I want my step down to be like 100 thousandths, and my step over to also be 100 thousandths. We'll see that this will regenerate, and it's going to capture those edits that we made. We'll just give that a second here to generate. One other thing you can look at is probably going to be done by the time we do this, but if I hit Task Manager, we can see this will show us everything that's in here. Say remove completed, and it's preparing some of the stock on the side. But this is a good way to see kind of what our toolpaths are doing as they're generating. So it looks like it's done. We can see again, if we click on this down here in the red, there is there's that box shown where we made the toolpath the limit, and then we can see down here there's some red areas in those holes where a toolpath would have been produced, and actually was produced, but then was later trimmed off by the boundary we selected. That looks pretty good. I'm going to hit Control Z to undo that. We can see this goes back to this version of that. And we can right click on the setup here and hit simulate. Now, because I have this machine in here selected on my setup, we'll be able to see that. And then I don't see my fixtures though. So I did turn those off while we were making some of the toolpaths just to make it look a little bit cleaner. So to activate the setup in the view down here where it says synchronize view and visibility, there's a sync view with active setup, which is going to show us the view cube. There's a sync visibility, which is going to show us all the parts that are related to our setup. This is kind of like an auto levels. So if I was coming from another system like Mastercam, where I'm used to putting things on different levels and then turning them on and off to see their visibility, it's going to do this automatically by activating these setups. You would activate that here by hitting this little black dot. So you can see when I click on this, it's actually going to show me the rest of my setup here, my fixtures, my vise, and everything that I have in there. So now when I right click on this and hit simulate, we'll see everything shown in the machine as it would be. So I can turn this transparency off, and we can hit play. You can see this is going to go through here and rough this out. It's kind of my rest roughing. This is my flat machining. And this is going through the 3D processing on this part. with that steep and shallow. So we can see we're doing a pretty good job of getting the coverage there on the top. Almost done with that. Then we're going to go into the drilling here. And that looks pretty good. So if I machine this part and I wanted to check it, there's a couple things we could do before we pull it off the machine. Now, if it does have to be remachined, I would rather do this in the machine and at least get some sort of verification before I take it off and maybe bring it over to a CMM. So let's go over to the inspection tab here, and I'm going to go to probing. And there's a couple of things on here. We can obviously set the work coordinate system, but that's not something we need to do right now. Probe geometry, this would be for geometric features. So if I wanted to measure like a height or a distance or the size of this block, we could do that. But there's inspect surface here. Now, a couple things we can do with this. I'm going to hit inspect surface, and we're going to come in here and choose a tool. If we don't have a tool in our own library, we can choose the Fusion 360 library here, and there's obviously a bunch. 6mm probe is what's going to be standard on like a Haas machine. You can hit select. I'm going to put in a speed rate here of 200, and then we're going to go to geometry. So here what we can do is we can actually touch some of these surfaces on here, and whether they're like flat surfaces, we would just be getting a reference here. And then we can actually pick on the model here, and this is going to give us a vector-oriented calibration, or not a calibration, but a vector-oriented touch point on the part. So we can grab these for reference and kind of see how much material is still remaining on these. This would give us a good idea of if we need to adjust something on the machine or recut something. We can look at my heights page here, probably lift this up a little bit. We'll hit OK. And then this would go through here, and while we're running this, we're not going to be able to show with the machine, but while we're running this, it's going to let us come through and inspect all these points on the part. And then it's going to write a text file that we can read back into Fusion 360 and see those deviations. And from there, what we could do is make a decision. Is this part good to take off? Do we need to remachine this, or are there some areas that still have excess material on there? And we can make a decision. The other thing is, if maybe I did pull this part off and I wanted to put it back on the machine, maybe I brought it over to the CMM, did some scanning, looked at it, measured some features on there, and I'm like, you know what? I figured out this needs to be remachined. We could use this same inspection cycle, and I'll turn on some of these leads and links so it looks a little bit more relevant, but we can turn on this inspection cycle, put the part back in there, and measure all these points, and then do a best fit for our program. So if we needed to redo this steep and shallow, we can come over here to probing and say part alignment, and then this will let us do a bunch of things here, whether we want to just move it in 3-axis, or we want to move it in 4-axis, like maybe we want to rotate it or adjust it if it was on a 4th axis. And in this case, it's on a 5-axis machine, so we can really move it in any position. So what this will do is it'll actually take where the part's sitting in the machine, and it's going to repost your program with the part alignment, so that no matter how it's sitting in there, if I just kind of put it back on there and roughly probed it in, it's going to give us a good origin and a good basically position for the part, for the component. From there, I'm going to just remove that real quick, and then from there, what we'd want to do is come over here and right click on our setup. We'd say post process. This is going to make an NC program, and here what I want to do is use a post. So this has a machine simulation post. This looks to be a little bit older of a machine that I had selected. Go to the cloud library here, grab a inspect surface post there. And then I'm going to turn this machine configuration off just for the way that I'm posting it. And we can right click on here and move to the machine model. We'll hit UMC 500, and we'll hit post. That's going to give us our code for the machine, and then we can go run that. So that's about it. We will open it up now for Q&A. Thanks a bunch, guys, and back to you.
Thank you for that, Devon. Appreciate you taking the time to go through that. We actually didn't have any Q&A or any questions pop up in the chat. However, I did post an email address in there if you do have any questions regarding what you've seen and you'd like to know any more information or schedule a demo, etc. The email is posted in the chat. It's actually fusion360@dsi-mfg.com. One other thing I want everybody to be aware of, that DSI actually support both US and Canada customers. We have a set of engineers that are, very versatile in a few different softwares, and we can support both countries. And also that we offer direct technical support, training, which can be via the web, via a Zoom meeting or on site. And we also support full post-processor services, customization, etc. So I do not see any further questions. So I would like to thank you all for taking the time to attend the webinar. Hopefully that some of you guys took away something from this and may show an interest and reach out. Again, we're available to answer any of your questions. Thank you for your time and have a good day. Thank you.